In today's lesson, we're going to learn about classifying triangles as acute, obtuse, and right triangles, and continue our work with finding the area. Now, just like we said, we can have a right angle, an acute angle, an obtuse angle. We can also have a right triangle, an acute triangle, and obtuse triangle. So let's talk a little bit more about those. So a right triangle has exactly one right angle. So you can see down here on this triangle, it has one right angle. So this triangle would be classified as a right triangle. And an acute triangle is a triangle with all angles measuring less than 90 degrees. So you can see this angle is less than 90 degrees, and this angle is an acute angle. It's less than 90 degrees. And we can see that this green angle is also less than 90 degrees. So we have three angles that measure less than 90 degrees. So this triangle would be considered or classified as an acute triangle. And finally, an obtuse triangle is one that has one angle measuring greater than 90 degrees. And so we can see that this purple angle is obtuse. It is greater than 90 degrees. And so in this triangle, it would be considered an obtuse triangle because it has that one angle that is greater than 90. So today, as we are finding the area of these triangles, we're first going to classify them and determine whether they are right triangles, acute triangles, or obtuse triangles. And then we will also continue practicing finding. So let's look at this first one. We have a triangle. We do have angles, 3 of them, right? Because we have this triangle. And the first thing I want you to do is just look and notice, see what you notice about the angles in this triangle. Are they acute? Are there any obtuse angles? Are there any right angles? So just look and see what you notice. And based on what you noticed, how would you classify this triangle? You can think it in your head. And if you said acute triangle, a cute little triangle, you would be right because all of these angles are less than 90 degrees. So this is an acute triangle. And now let's find the area of this acute triangle. Remember, to find the area of the triangle, we need to find the base and the height. And any one of these sides could be the base, but the key is that the height must form a perpendicular line with the base, meaning that the height has to form a right angle with the base. So let's just problem solve this. If we wanted this side, 54 centimeters, to be the base, is there any measurement that we have that would be running perpendicular? Remember, it has to run at a right angle. One of those wasn't very good here. We don't have that measurement. So really that side, that purple side, does not make sense to use as the base. But if we look at this side, 60 degrees or 60 centimeters, do you see how we have this perpendicular line that forms, and it forms that 90-degree angle down here with the base? That should be our base then. So our base is going to be 60 centimeters and our height is going to be 45 centimeters. So will you find the area of this triangle? All right, let's check in to see your thinking. So we know that to find the area of a triangle, we need to take half of the base times the height. So if the base was 60 and the height was 45, let's multiply 60 times 45. And 60 times 45 is 2,700. And so if we take half of that, remembering that of in math means to multiply. So 1/2 times 2,700, or we know that if we're taking half of it, we're dividing it into 2 equal parts. Let's divide 2,000, and when we divide 2,700 by 2, we get 1,350. So the area, the space inside of this acute triangle, the area inside is 1,350 square centimeters. So if we had some little squares that measured 1 centimeter on each side, we would be able to cover the space of this triangle with 1,350 of those squares, based on a base of 60 centimeters and a height of 45 centimeters. Let's look at this next triangle. The first thing I want you to do, again, is look at the angles in this triangle. What do you notice? And how does that help you to classify what type of triangle this is? Is it acute triangle, an obtuse triangle, or a right triangle? And be able to tell how you know. Okay, if you were thinking that it is an obtuse triangle, you would be correct because of this one angle that is greater than 90 degrees, right? It's got its mouth wide open, really wide open. So this would be an obtuse triangle. Now that we know that, let's find the base and the height, and then find the area of this obtuse triangle. So remembering that the base can be any one of the sides, but the height must form a perpendicular line or form a right angle with the base. So if we use this side as our base, and we can see that we have to extend out that base in order to find the height of 21 feet. But do you see how this forms a right angle? So we have the height is the perpendicular line to the base, and now we're able to find the area of this triangle because we know the base and we know the height. If we multiply the base times the height and then take half of that, you'll have the area of this obtuse triangle. So go ahead and find the area of the obtuse triangle and then check back to see if you're thinking. So we knew the base was 33. We know the height was 21. So when we multiply 33 times 21, we get 693. And now we are ready to take half of 693, or 1/2 times 693. And to find half of something, we're dividing it into 2 equal parts. So 693 divided by 2 is 346. We did have a remainder of 1, but remember that remaining part becomes the numerator and the divisor is the denominator. So we have 346 and 1/2. So the area of this obtuse triangle would be 346.5 square feet, or feet squared. Don't forget your label of square units when you're labeling. This next triangle, you know what I'm going to ask you to do. Start by looking at the 3 angles. What do you notice about these 3 angles, and how does that help you to classify this triangle? Did you notice that we have a right angle? That's what that little square means. So this would be classified as a right triangle. And now let's find the area. I'm going to leave you to think about what is the base of this triangle and what is the height, remembering that they must form a right angle. The base must form a right angle with the height. They have to be perpendicular. So find the base, find the height. That will help you to find the area, and then check back. So when you were looking at this triangle, hopefully you saw that the base had to be 35 because the height, which has to form a perpendicular line with the base, so there's the length that has the right angle, so the height was 55. So when we multiply 35 times 55, we get 1,925. And so now we're going to take half of 1,925, and just so you know why we divide by 2, if you were to actually multiply these two, going back to our work with fractions, we have the whole number 1,925. Goodness, sorry. If we put that over 1 and we multiply the numerator times the numerator, 1 times 1,925, we get 1,925. And denominator times denominator, which is 2 times 1, we get 2. And so we actually get the division problem, because remember fraction is also a signal of division, 1,925 divided by 2. So in your mind, if you didn't know that finding half of something is dividing it into 2 parts, you could also go back to your background knowledge on fractions and multiplying whole numbers times a fraction. So when you divide 1,925 by 2, we get 962 with 1 left over. That leftover part becomes the numerator, and the divisor is the denominator. So 962 and a half is the area of this right triangle, 962 and a half square. The next few problems we're going to look at are going to require you to do a little thinking. They don't just give you the measurement of the base and the height. You have to have a little background knowledge in geometry and some of the symbols in geometry. So I want to point some things out to you that will help you kind of think through these next few problems. So I want you first, let's classify this triangle, of course. So if you look at the angles, do you see acute angles, obtuse angles, any right angles? Hopefully you notice this one obtuse angle down here. Its mouth is really wide open, so of course this is an obtuse triangle. And now that we've done that, now that we've thought about that, the next thing I want you to think about is, or notice, are these little double tick marks. In geometry, when we have those tick marks, sometimes it will be 1, okay? It might just be a single line. Sometimes they'll use 2 tick marks, like down here. That's showing that those 2 lines indicated are of equal length. So if this, and this is not the case obviously, but if this line had 1 tick mark and this side had 1 tick mark, they would be telling you that these 2 sides are equal in length. That's what these 2 single tick mark lines would show. Now we know that's not the case because those lines are not equal in length. But what they're showing us down here with the double tick marks is that this length and this length are equal in length. So they don't tell us the measure of this base, but we know that the whole sides measure is 72. And so if we were to divide 72 in half, which is what they're doing, if we were to divide it in half, then we would know what that base's measure is. So 72 divided by 2 is 36. So we know that this side length's measure is 36 and this side length measure is 36. And now we can use that information because now we know what the base is, we can see what the height is, and we can take half of that to find the area of this triangle. So do that now and then check. So the base we found was 36. the height, so here's our base of 36. Here's our height of 50 inches because it forms that right triangle. Now we know that 36 times 50 is 1,800. So we need to take half of 1,800. And when we divide 1,800 into 2 equal parts, we get 900. So the area of this obtuse triangle is 900 square. All right, let's look at another triangle where we're not exactly given the measurement of the base and height, but we are given other measurements that will lead us to the base and height measurement. So we're looking at this triangle, and there we go. We're looking at this blue triangle, and right away I can identify the base and the height because they form that right angle, right? They're two perpendicular lines. So here is the base, and the base is in yellow and the height is in green, right? They meet at a 90-degree angle, so we have the base and the height. But I'm sure you're noticing that there's no measurement listed for the base. There's no measurement listed for the height. All we have are these measurements over here of these step little structures. And so how are we going to use those measurements to help us find the length of the base and the length of the height? Remember that those little tick marks indicate that we have similar or same length sides. So each of those sides marked with that one tick mark that I just highlighted in red, those are all the same length. So we know that this side is 14 centimeters. We know then that this side is also 14 centimeters, and this side is 14 centimeters, and this side is 14 centimeters. So knowing that, I want you just to pause and think about how you might use that information to help you find the length of the base and the length, of the height. Okay, so let's look at the lengths that are going to help us figure out the length of the base. So I've color-coded the lengths different colors. If we look at this kind of frozen blue color, and I just bring that length down here along the base, we know that that length is going to be 18. It's the same length as this line segment up here. And if we take that purple color up there and we bring it right down below, it's as if we're just pulling it down to the line below, then we can see that this length and this length will be equal. And then if we grab that orange length up here, 14 centimeters, and bring it down here, then we can see that that length will also be the same length as the line up there. So now we have these three lengths down here. We have 18 centimeters, this was 14 centimeters, and 14 centimeters. So now we can find the length of that base. We simply need to add 18 plus 14 plus 14, 16, and 1 plus 1 plus 1, plus one more is 4. So that base is 46 centimeters. And again, we found that because we used the lengths that we were given, this 18 centimeters, 14 centimeters, 14 centimeters, and we just visually moved those line segments down, and we could see that they were the three parts of that base line segment. Now, let's try to see if we can figure out. Okay, again, we've color-coded this so that we can see that this orange length, which is 18 centimeters, can be visually just dragged over here. And this side then is also 18, or this length over here is 18 centimeters. And then we can look at that purple length, which is also 18 centimeters, and line it up over here. So it's just as if we slid that right over there, and just as if we slid that orange length over there. And so we have another 18 centimeters. And then if we slide that 14 centimeter line over, that should finish off the measurement of the height. So again, to find the height, we just need to combine those three lengths, 18, 18, and 14. So when we add those, 8 plus 8 is 16, plus 4 is 20, 2 plus 1 plus 1 plus 1 gives me 5. So the height would be 50. So now we can find the area of this triangle, because we know that the area of a triangle is 1/2 times the base times the height, or taking half of the base times the height. We now know that the base measurement is 46. The height of the triangle is 50. And so if we take half of 46 times 50, we will have the area of this triangle. Solve that and then multiply 46. Okay, so when we multiply 46 times 50, we get 2,300. And our next step then is to take half of 2,300. And when we take half of something, we're dividing it into 2 equal parts. And so 2,300 divided by 2 gives us 1,150. So the area of this triangle would be 1,150 centimeters square, or square centimeters. And we forgot to classify this triangle, but if we were going to classify this triangle, hopefully you saw this right angle down in the corner. And so we know that this would be a right triangle. All right, let's look at this last one together. We are needing to find the area of this triangle. I'm going to highlight it in blue. Let's make that a little bit thinner, shall we? All right, if we have this blue triangle, and we can't really tell which one is the base. We can't really tell which one is the height. We're not really given any of those measurements very clearly, but we do notice a couple of things. Hopefully you notice these tick marks showing me that these line segments, this line segment is the same length, or that green line segment is the same length as this red line segment, is the same length as this, let's do purple, as this purple line segment. So those 3 segments are the same length. I see that the opposite side of this square is 108 feet. So how can I use 108 feet knowing that its opposite side is divided into 3 equal parts? How can I use that to help me find this measurement? And if I find that measurement, then I can see that this red line forms a 90-degree angle with that purple line. So the purple line could be my base, and this red line could be my height. And I can see that the opposite side is 108 feet. So that tells me that this side is 108 feet, because opposite sides are equal in length. And so then I could find the area of this triangle. So think through that a little bit. Go ahead and once you found the length of the base, find the area of this triangle, and then check back in to see if you're thinking. All right, so hopefully you found that you needed to take 108, the total measurement of this purple side, and to find the base over here, we needed to divide that by 3 because we were dividing 108 into 3 equal parts. And when you divide 108 by 3, you get 36. So we know now that the base is 36 and the height is 108. And so we can take half of 36 times 108. And 36 times 108 is 3,888. And so next, you need to take half of that, so half of 3,888. When you take half of something, you're dividing it by 2. And so 3,888 divided by 2 is 1,944. So the area of this triangle would be 1,944 square feet. So in this lesson, we talked a little bit about classifying different triangles. We know that a right triangle has exactly one right angle. An acute triangle is a triangle with all angles measuring less than 90 degrees. An obtuse triangle is a triangle that has one angle measuring greater than 90 degrees. We then practiced finding the area and classifying different triangles. And then we did a few trickier triangles where we were given measurements of, lengths, but not necessarily given the exact base or height. And so we used clues like these tick marks that mean that these two sides have the same length. We used those clues to help us solve finding that missing length measurement, and in order to find the area